Other types of work. The first one is stretching of wire. Let us consider a wire of a cross-sectional area A. Let us consider this wire which has got end, it is length L, length L. When the external force of that is the tension force is applied, then it will change into certain length. That the change in length we call it as a dl. Now, infinitesimal work done is given by GW is equal to F into dl, but it is negative. The negative sign indicates work must be done on the wire to affect a change in its length. Therefore, negative sign it is due to work done on the wire. Work done on the wire. Means out of reversible process. If the process is reversible, we studied the five different forces, that is constant pressure, constant volume, isothermal, polytropic, and adiabatic. Now, other types of work like stretching one type, that is stretching of wire. If problem arises based on stretching of wire, we have to solve in this particular way. Now, we know that based on Hooke's law, there is a stress is directly proportional to strain, and at the same time, we know that there is the stress is also defined as force by area. Now, this stress based on Hooke's law, that is, if you remove the proportionality constant, you will get elasticity modulus. Then stress can be written as E into this strain. Therefore, this equation becomes E loss at the strain F by A. Therefore, F is equal to E A and strain. Therefore, F is E A strain. And strain is nothing but change in length divided by original length. Therefore, dl is equal to L into strain. So this is strain. Therefore, dl is equal to L into dE. Because these two, I will take it here, and dW is equal to minus F E A. This strain. This is strain. Into dl it is L into strain. Therefore, what I'll minus EAL, which is one term I will take, then EGE. For a two states, if I integrate dW is equal to integral 1 to 2 minus EAL into you are integrating with respect to strength, which is W1 to 2 is equal to minus EAL integral 1 to 2 strain into GE. Therefore, this is minus EAL E2 square by 2 minus E1 square by 2. This is the work expression. This is the work expression. It is this one minus EAL for a stretching of wire. So W1 to 2 is minus EAL E2 square by 2 minus E strain E1 square by 2. This is the work expression for stretching of wire. Next type of work is electrical work. In that electrical work, if I consider a resistor where a charge is flowing, where the current is flowing, if I consider a resistor, this is resistor, and current I is flowing in the resistor, and resistor gets heated up. When a current flows through a resistor taken as a system, there is a work transfer into the system. This is because the current can drive a motor. The motor can drive a pulley and pulley can drive a weight that we studied work according to thermodynamics. Therefore, the current flow which is given by in ampere is equal to dc by dt, where c is the change in the coulombs and t is the time in seconds. Time in seconds. If E is the voltage potential, if E is the voltage, potential voltage, then work is given by the elemental work or infinitesimal work done dW is equal to E into dC. Therefore, dC can be written based on this. dC can be written as I into dt. Therefore, dW is equal to E into I dt. Then if I integrate over two states, dW is equal to 1 to 2 EI into dt. Therefore, W1 to 2, W1 to 2 is equal to 1 to 2 EI dt. This is the work expression for electrical work. One is E is the voltage or voltage potential, or I is the current flow. That is in ampere. That I is in current flow, which is in ampere. Then electrical work is given by like this. Then this is electrical work. The third type of work, that is a shaft work. And shaft work, if a motor is connected to shaft, let us consider one motor which is connected to shaft. This shaft, and considering shaft as a system, the dashed line indicates that we are considering only shaft as a system. Then it rotates. Then rotational forces torque, and with a certain speed, let me take the speed as a n. When shaft taken as a system is rotated by a motor, there is a work transfer into the system. This because the shaft can rotate a pulley which can raise a weight. That is also we can tell that is work according to physics. That is the displacement of the work. If T is the torque applied to the shaft and d theta, T is the torque, and d theta is the angular moment. That is d theta. It is angular displacement. I will call angular displacement. T is the torque, and the change, that is angular change, that is angular displacement of the shaft, that is given by W is equal to 1 to 2 T d theta. Very important expression. W is equal to F into L we are writing, F into dV we are P into dV we are writing, F into dl we are writing. As it is a force, W in a stretching of wire you write W is equal to F into dl. Instead of linear force we have a rotational force. With linear displacement we have a angular displacement. This is shaft work. And shaft power can also be calculated, which will be very helpful in your problem. Shaft power, that is SP, I will give you the notation, that is T omega. That is omega can be written as 2 pi n t. This is the shaft power, 2 pi n t. That is omega, that is angular velocity. That is omega is equal to theta by t. That is angular displacement divided by t. That is angular velocity, radians per second. This is shaft work. Next, paddle wheel work, or another name it is steering work. Steering work. It is, I will consider a system which has to be agitated through some gas or some liquidity there. I'll give a stirrer here, that is paddle wheel or a stirrer, whatever it can be. That is connected to one system where due to the rise and lowering of this dead weight, that stirrer will rotate and systems get agitated. As the weight is lowered and the paddle wheel turns, this one is paddle wheel turns, then work is done on the system. There is a work transfer into the fluid system which gets stirred. Since the volume of the system remains constant, this volume remains constant. For a reversible process, I can tell integral PdV is equal to 0 because there is a volume constant. That means if I consider fluid as a system, volume remains constant. There is no change in volume. Therefore, one can tell that integral PdV is equal to 0. That is for a reversible process. And if m is the mass of the weight lowered, m is the mass of the weight lowered, then lowered through a distance of dz, there is a change pattern after lowering, that is distance, and p is the torque transmitted, that is rotational force, and dt is the angular displacement. Then one can write the steering work, that is equal to 1 to 2 t d theta. That is same as your shaft work, and also in terms of mass I can write, that is integral 1 to 2 mg dz. This is also true. On the surface of a liquid has a surface tension, has a surface tension, where which is a property of the liquid, and the surface tension acts to make the surface area of the liquid minimum. It has the unit force per unit length, that is force per unit length, Newton per meter. Surface tension, the notation is given rho. Therefore, work done in a homogeneous liquid film in changing the surface area, is given by W is equal to rho 1 to 2 surface tension into dA, and it is negative. Remember this. This is work done on the system minus it is rho 1 to 2 surface tension into change in area of the film. That is the work done for a surface, a liquid film where the surface tension comes to picture. That is change in area of surface film. Magnetization of a paramagnetic solid. The work done for unit volume on a on a magnetic material, on a magnetic material through which the magnetic and magnetization field are uniform. For a magnetic material, we can calculate the work done, that is integral 1 to 2 h into di, and that is also work done on the system negative sign, where h is the magnetic field strength, and I is the component, I is the component of magnetization field, magnetization field in the direction of, that is very important, in the direction of the fluid or flow or fluid flow. 1 kg of air contained in a closed system at 100 kilopascal. Mm, 100 kilopascal and 300 Kelvin is compressed 1 kg. Let me write it down. That's false. 1 kg m is equal to 1 kg. It is contained in a closed system at 100 kilopascal. P1 is equal to 100 10 to the power of 3 Newton per meter square, and 300 Kelvin. Temperature is 300 Kelvin. Is compressed isothermally. It means is contained in a closed system. Let me take the system of the piston and cylinder arrangement. Yes, this is the piston and the cylinder arrangement. And this is the initial state. Till the volume has, it is compressed isothermally. That means volume decreases. This will be the second state. This will be the second state. It is compressed. It is compressed. It is compressed. Initial volume is V1 and final volume is V2. Therefore, V2 is half of the V1. That means, what I said, it is compressed isothermally till the volume has, that means final volume is half of the V1. Therefore, V1 is 2 times of V2. That we can grasp from here. V1 is 2 times of V2, or V2 is half of the V1. During the process, it is also stirred with the torque. That means whatever the system inside the system, this system is in a resonance. If I consider a gas or any system, then that particular system is also stirred with the torque of 1 Newton meter at 400 RPM. Capital M, that is 400 RPM for 1 hour. That means time is 1 hour. That is small t. Calculate the net work done on the system. Assume R is equal to 0.285 into 10 to the power of 3 joules per kg Kelvin. I'm writing it in basic unit to get the answer in joules. Joules per kg Kelvin. Yes. Now, let us analyze this problem. We've got two things. One is isothermal process and another one is stirrer work. Therefore, net work done, it is one is isothermal work, or else I will call it as integral PdV work, and another one is stirrer work. Let us calculate one by one. If you write this as equation 1, let us calculate integral PdV work first. Now, integral PdV work is the process is isothermal process. For isothermal process, work done is given by, that is during the change of state, that is PD I will be right. That is P1 V1 ln V2 by V1, or else W, you can write W1. You know P1, you don't know V1. And V2 by V1 ratio is given. That is P1 V1 ln V2 by V1, it is 1 by 2. Ln V2 by V1. V2 by V1 is 1 by 2. That ratio is given. Therefore, our task is to, this is known, this is known, this is the unknown term. Let us find that V1. We know ideal gas law, perfect gas law, P1 V1 is equal to Mr T1. V1 is equal to Mr T1 divided by V1. Here M we have to keep it in kg. This is in joules per kg Kelvin. Temperature in Kelvin, pressure in Newton per meter square. Then the answer you will get it in meter cube. Therefore, V1 is equal to M, mass is 1, R is equal to 0.285 into 10 to the power of 3. P1 it is 300 Kelvin, and the P1 it is 100 into 10 to the power of 3. Then you will get the answer V1 in a meter cube. At V1 you will get 0.861 meter cube, 0.861 meter cube V1. Substitute here, but W1 to 2, you will get P1 100 into 10 to the power of 3 and V1 0.861 into ln 1 by 2. Then we will get W1 to 2, it is minus 59.67 into 10 to the power of 3 joules, or else minus 59.67 kilojoules. This is the work expression work for a isothermal process. Now this is done. Now our task is to find trigger. And at the same time, even you can make a simpler here. Therefore, this can also be written, and this expression can also be written as P1 V1 can also be written as MRT1. Therefore, it can be written as MRT1 ln V2 by V1. This M is known, R is known, T1 is known. Therefore, directly you can substitute here and you can calculate, or else you can calculate V1 and you can get the W1 to 2. The R is given particularly. If R is not given, if they mention gas or a air, then you should remember R is equal to 0.287. Here particularly they given 0.285. Therefore you should take this 0.285. Next is stirrer work. We know stirrer work is given by W stirrer. It is work done on the system. Therefore it is minus 2 pi n T. See, this is T omega is shaft power. Therefore, one more T will come, that is time. This is shaft, stirrer work, minus 2 pi n T into small t. Then the answer will get it in joules. When you will get the answer in joules, if you substitute n in revolution per second, this is in Newton meter, and this is in seconds, then you will get the answer in joules. Therefore, let us substitute that W stirrer is equal to minus 2 pi. N they have given, it is in RPM, that is 400 RPM, revolution per minute. To convert into seconds, I will divide it by 60 to convert into seconds. That is torque. Torque they have given, it is 1 Newton meter. They have mentioned torque here. Yes, torque here it is 1 Newton meter. Torque is 1, and time, that is important here. They have mentioned in hour, that is 1 hour. Therefore, 1 hour you have to convert into seconds. It is 1 into 60 will convert into minutes, and another 60 will convert into seconds. Therefore, W stirrer, it is minus, after substituting all this, you will get minus 150.87 into 10 to the power of 3 joules, or else you will get minus, or else you can write minus 150.87 kilojoules. This is the stirrer work. Therefore, net work done, it is integral PdV work plus integral stirrer work. We got the two values, and we get, after substituting this, minus 210.54 into 10 to the power of 3 joules, or else minus 210.54 kilojoules. Both are correct. Next problem, a piston and the cylinder arrangement containing a fluid system. A piston and cylinder arrangement containing a fluid system and a steering device in the cylinder as shown in the figure. The figure is piston and cylinder arrangement. There is a stirrer. This is a system. They have given piston and cylinder, the same thing. And the steering device in the cylinder as shown in the figure. The piston is frictionless and is held down against the fluid due to atmospheric pressure. It means initial state is this. As the system exerts certain pressure, even after hesitating of the stirrer, it is balanced the forces. This force is balanced by the atmospheric forces or atmospheric pressure. Then it will be in equilibrium state, and that is state 1. Atmospheric pressure is 101.325. The steering device is turned 10,000 revolutions. Atmospheric pressure, I will write atmospheric pressure, that is 101.325 kilopascal, that is 10 to the power of 3 Newton per meter square. The steering device is turned 10,000 revolutions. The total revolution, it's not n, it is revolutions. That means the given data here, it is n into t over stipulated time n, and over stipulated time, uh, and the speed nt is 10,000 revolutions with an average torque of 1.275 newton meter. This is torque. Meanwhile, the piston of 0.6 meter dia moves out 0.8 meter, 0.8 meter. The piston of 0.6 meter dia moves out 0.8 meter. Moves out 0.8 meter. That means moves out. This will go in this side. So this particular one moves out. Therefore, this distance move out, it is 0.8 meter. The diameter, it is 0.6 meter. The diameter is 0.6, and this move out, this distance, it is 0.8. Therefore, this particular becomes there, and this particular move becomes stroke, moves out. It means then. Therefore, dia of the piston is given 0.6 meter, and the stroke becomes 0.8 meter. This is outwards. Piston moves outwards. Okay. Indirectly, they have given swept volume because diameter and stroke is given to calculate this volume change, swept volume. Okay, and one more important thing we should remember, they have given total revolutions. Therefore, revolutions is given by NC, that is this step is important. Let us calculate, same thing here. There are two things. One is the net work done, which is calculated by integral PdV plus, and one more work, it is scissor work. This integral PdV work you have to identify because the system is moving against atmospheric pressure. Therefore, it is constant pressure forces. Therefore, let us calculate first integral PdV work. Integral PdV work, it is constant pressure forces. Constant pressure forces. That is, work is given by W1 to 2 PdV. Integral 1 to 2 PdV, or it is given by P into V2 minus V1. P is atmospheric pressure. Atmospheric pressure is given. What is this V2 minus V1? This distance. This is in, if I tell in terms of volume, this V2 minus V1. This is the volume swept from first state to the second state. Therefore, this is nothing but a swept volume. Therefore, to calculate the swept volume, that is Vf, that is V2 minus V1. Therefore, V2 minus V1, Vf, it is given by pi d square by 4 into n. It is V2 minus V1. That's why the diameter and stroke is given. Substitute that pi diameter 0.6 square divided by 4, n is 0.8, you will get V2 minus V1. Therefore, V2 minus V1, you will get 0.226 meter cube. This is the swept volume. You will get 0.226 meter cube. 0.226 meter cube. Substitute here W1 to 2 P atmosphere. P atmosphere, that is 101.325 into 10 to the power of 3 V2 minus V1 0.226. That is equal to W1 to 2. It is you get W1 to 2 229 1 9.17 joules, or else it is 22.91917 kilojoules. This is the what is that? Integral PdV work. For identification here, it is a constant pressure process is important. Previous problem they have given isothermal process, particularly mentioned they have isothermal. It is compressed isothermally. Therefore, you got negative. Here it is moving outwards. That means obviously the process will be expansion process. You can tell that process. I mean, whatever you will get a positive. That the solution is correct. Next is stirrer work, and stirrer work you are familiar now. Stirrer work it is calculated minus 2 pi nt will give you the power, stirrer power or shaft power, multiplied by time will give you the work done, that is joules. Then the n t is given, therefore I will rearrange the term minus n small t. This is given, that is revolution, that is minus 2 pi nt, it is 1000, and the torque it is 1.275. Then stirrer work will become the stirrer minus 80,110.61 joules, or else minus 80.11061 kilojoules. Therefore, net work done, it is integral PdV work plus stirrer work, that is equal to, you get minus 57,191.44 joules, or else minus 57.19144 kilojoules. This is the work done. Next problem, it is based on surface tension. Surface tension of a soap film. Surface tension of a soap film having a hoop diameter of 0.06 and inner diameter. See, if I take a bubble, the hoop diameter it is the outer one. The hoop diameter it is the outer one. That is, this outer diameter it is 0.06 meter, and the inner diameter it is this one. I will call it as the d high inner diameter 0.03 meter. The surface tension is rho. Surface tension of a soap film having a diameter is 40 into 10 to the power of minus 5 Newton meter. That is, surface tension is given Newton per meter. Hoop diameter, outer diameter, and inner diameter. Now, surface tension work is given by W1 to 2 integral minus integral 1 to 2 surface tension, and it is a change in area. Therefore, you are integrating with respect to area. Surface tension is a constant, and I am bringing outside 1 to 2 dA. And surface tension integral of 1 to 2 dA, you will get A, and the limits are 1 to 2 minus rho. This is A2 minus A1. And since it is a circular process, circular bubble or a soap film, you get A2 as 5V square by 4 D2. A2 which is inner and outer, that is D0 here. D2, or else I will call D0 as D2, inner diameter as a D1. Therefore, this will become D2 square by 4 minus 5D1 square by 4. Therefore, W1 to 2 is minus sigma, surface tension minus rho 40 into 10 to the power of minus 5 pi d2 square. D2 square is 0.06 square divided by 4 minus pi d1 square 0.03 square divided by 4. Then after substituting surface, area in change of the film, you will get minus 8.48 into 10 to the power of minus 7 joules. This is the work done of based on the given data. Important problem is consider the system shown in figure. The figures are right here. Is piston and cylinder arrangement. Inside the cylinder, there is a gas, and a spring is also connected which exerts certain amount of pressure. This is the figure. Initial condition of the gas, that is V1, let me write it as V1, 0.1 meter cube, 0.1 meter cube, P1 200 kilopascal, 200 into 10 to the power of 3 Newton per meter square. The atmospheric pressure is 100 kilopascal. Atmospheric pressure is 100 into 10 to the power of 3 Newton per meter square. The spring exerts a force. The spring exerts a force. If it is exerting a force, that means gas also exerts a force, and this spring is also exerts a certain force. Let me write it as a spring, and there is also certain force which is acting on the piston from the atmosphere. That's why they have given atmospheric pressure. In previous problems, we are solving like gas is exerting pressure which is balanced by the atmospheric pressure. And here, if I consider the force exerted by the gas here, which is balanced by atmospheric force and spring force here. That is additional thing here is spring force. And also they mention the spring exerts a force which is proportional to the displacement. That means spring force exerted by the spring which is proportional to the displacement, and let displacement, let me give it as a x. This is important, which is given in the problem. The gas is heated until the volume is doubled. That means V2 is equal to 2 times of V1, and P2, which is also given, which is 600 into 10 to the power of 3 Newton per meter. Determine the work done by the gas. Now the work done by the gas we will calculate. Before going to calculate, let us using the force balance equation. Let us balance the force. Let us balance the force. That is, force exerted by the gas is equal to force exerted by the one is atmosphere, and another one is force exerted by the spring. Now we know pressure is calculated by force per unit area, Newton per meter square. Force exerted per unit area. Therefore, F can be written as, here F can be written as P into A. That is P into A. Similarly, this atmospheric pressure is acting on the piston. Therefore, P atmospheric into same cross. This is also same cross-sectional area of the piston. Here also same cross-sectional. Therefore, this is the pressure exerted by the gas is equal to this atmosphere. Pressure is atmospheric pressure, and it is acting on a same cross-sectional area of the piston. Like F spring. F spring is this. F spring, which is proportional to X displacement. If I remove this proportionality symbol, you will get a proportionality constant here, that is K into X, where K is, that is the stiffness constant of the spring. Stiffness constant of the spring. X is the displacement. F spring is equal to Kx. Therefore, F spring, I can write it as a K into X. And also we know that V is equal to A into X. That means this is meter cube and this is area meter square. Yes, volume I can write area into displacement, meter square into meter. Now X I can write here B by A is equal to X. Therefore P into A is equal to can be written as, x can be written as V by A. What I'm trying to write is trying to keep it in terms of area, every expression in terms of area. Therefore, P is equal to, I'll take area on the other side, P atmosphere area by this A plus K into B by A is already there, one more area. Therefore, it will become P is equal to P atmosphere, area cancels there, then KB divided by area into area, it is A square. That is, what I am trying to write here is area in terms of volume. Therefore, for a reversible process, integral 1 to 2, it is P dV. Integral 1 to 2 is P dV. And P is 1 to 2, that is P atmosphere plus kV by A square into dV. That means separate it 1 to 2 P atmosphere into dV plus 1 to 2 kV by A square into dV. P atmosphere I can take outside and the integration become 1 to 2 dV. If here K by A square I can take out 1 to 2. As area is constant and also stiffness is constant, I can take out 1 to 2 V dV. Now after doing the integration, this will become W1 to 2, that is the P atmosphere dV, that will become V1 to 2 plus K by A square. And if you apply the limits, it is V square by 2, limits are 1 to 2. Therefore, W1 to 2, P atmosphere, apply the limits V2 minus V1 plus K by A square. K by 2A square I will write, this is V2 square minus V1 square. Now, by looking at this expression, the second term, that is V2 square minus V1, that I can write, it is of the form A square minus B square. Therefore, it is what? A plus B into A minus B. Now, I can take out V2 minus V1 common term from both the terms, that is, you remain with your P atmosphere plus K divided by 2 A square into V2 plus V1. This is W1 to 2. Therefore, multiply here K W1 to 2 V2 minus V1 I keep as it is. Then P atmosphere I keep as it is plus K2 A square V2 plus K divided by 2 A square V1. Let me keep this as a star. Now we know that by expression, that is equation 1, what it says, P is equal to P atmosphere plus kV by A square. This is 1. Therefore, kV by from this kV by A square, I take this to the left hand side, then it will become P minus P atmosphere. If I write it for a initial volume, therefore that will become kV1 by A square. Area remains constant. P becomes P1. Yes, this is for a first state. Or else state 1. For a state 2, I can write kV2 A square is equal to P becomes P2 minus A atmosphere. That means this is in terms of P1 or state 1. This is in terms of state 2. This is B. Now here, this star equation what I have written, this is kV2 2A square. kV2 2A square is P2 minus P atmosphere. Therefore, star becomes W1 to 2 is equal to V2 minus V1 into P atmosphere. First term remains same. Then kV2 square, that is half into P2 minus P atmosphere plus half into P1 minus P atmosphere. Therefore, W1 to 2 is equal to V2 minus V1 into P atmosphere plus half P2 minus half P atmosphere plus half P1 minus of P atmosphere. Minus of the atmosphere minus of it becomes minus 1. Therefore, P atmosphere distance cancels and you remain with W1 to 2 V2 minus P1 and the remaining thing is P2 plus P1 divided by 2. Now you have a P1 value and a P2 value. Substitute that W1 to 2 V2. V2 is how much? It is doubled 2 times of the V1, 2 times of the V1 minus V1 into P2. P2 is 600 into 10 to the power of 3 plus P1, 100 into 10 to the power of 3 divided by 2. This is W1 to 2, 2V1 is V1, 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 that V1 is how much? 0.1. V1 is equal to 0.1 and V1 will get it is how much? 0.1. Then W1 to 2. For W1 to 2, you will get the final this one value for W 40,000 joules, or else you can write 40 kilojoules. This is the work of when the piston and cylinder arrangement. The gas is exerted pressure and it is balanced by the atmospheric pressure and also spring pressure. That when we balance the force, that is a force exerted by the gas is equal to force atmosphere plus spring. What we did here is we express P in terms of volume. P you are indicating with respect to volume, therefore I need an expression of P in terms of volume. I got that. Then it's a simple mathematical step to get the answer of 40,000 joules. Next problem, a fluid contained in a horizontal cylinder with a frictionless leak-proof piston is continuously agitated. A fluid contained in a horizontal cylinder. Let me write that horizontal cylinder. Horizontal cylinder. Horizontal cylinder, which is there is a fluid inside that cylinder. It is continuously agitated by the stirrer. That means there is a stirrer which continuously agitates this. The cylinder dia of 400 mm. Now, what are the data given? The diameter is 400 mm, 400 into 10 to the power of minus 3 meters. During the stirring process, the time lapse is 10 minutes. That means time it is given 10 minutes. The piston moves slowly through a distance of 490 mm. That means it is stroke. It is moving 490 10 to the power of minus 3 meters. Piston is moving slowly. That means the displacement of the piston, that is, it is given in meter, not in volume. Therefore, it becomes stroke. The atmospheric pressure, that means atmospheric pressure, it is 1 bar, 1 into 10 to the power of 5 Newton per meter square. Therefore, there is a atmospheric pressure which is balancing the force exerted by the liquid. Therefore, it will become what? It will become a constant pressure process. Whenever you get a atmosphere, it is balanced by atmosphere and or some data related to atmosphere, they will give. Therefore, it will be in equilibrium position if and only if there is a atmospheric pressure at the other side of the system. The net work done on the fluid during the process. The net work done they have given. Net work done on the fluid. That is very, very important. That is net work done on the fluid, which is very important. Net work done on the fluid. On the fluid. Net work done on the fluid. Therefore, W net, which is on the fluid, minus sign convention for work done on the piston is minus, that is 1965 Newton meter. Newton meter is nothing but a minus 1965 joules. Joules. Work done on the system. Therefore, next, if the speed of the electric motor driving the stirrer is 750 revolution per minute, that is N is given 750 revolution per minute. These are the data they have given. A fluid containing a horizontal cylinder. One more time I will write. Horizontal cylinder which is agitated by a stirrer, and whatever it exerts, it is balanced by the atmosphere. Fluid is there, which also exerts pressure, which is balanced by atmospheric pressure, and the process is constant pressure process. Agitating the cylinder. The piston moves slowly through a distance of 490 against atmospheric pressure. The net work done on the fluid during the process is 1965 Newton meter. If the speed of the electric motor driving the stirrer, that means stirrer is drawn by one more device, that is motor. Motor. That means stirrer is operated by a motor. Compute the torque in the driving shaft. This torque we have to calculate, and also shaft power output of the motor. Next, the electric motor is supplied with a current of 0.9 ampere from 24 voltage battery. That means motor is run with the help of one more device, that is battery. This is the setup what they have given. We have to calculate first one, it is compute the torque. That means torque T here in the shaft, driving shaft, and shaft output of the motor. This means and also shaft power output of the motor. This output of the both the things we have to calculate of a motor. Next, the electric motor is supplied with the current of 0.9. Compute the network of the battery. That means work of the battery we have to calculate, and also work of the motor we have to calculate. These are the two tasks for us. Let us calculate one by one. One is torque, and another one is shaft power. Okay. First, let us calculate what are the net work done. Net work done, it is net work done for this one piston and cylinder arrangement here. The net work done for this particular one, net work done is integral PDV work and stirrer work. Therefore, net work done is integral PDV work and stirrer work. Integral PDV work, it is constant pressure process, integral 1 to 2 PDV, that is P into V2 minus V1. That is P here, it is atmospheric pressure, and V2 minus V1. That V2 minus V1 here, that's why they have given this diameter and stroke. The piston moves slowly through a distance of 490. If it is moving through a distance of 490 mm, this is the stroke. Corresponding volume will be swept volume. Therefore, the swept volume, it is V2 minus V1. That is the piston and the cylinder arrangement. If this is the piston initial state, and if this is the final state, if it is moved along with the L, corresponding volume, if I call Vs, this is the V1, the difference in volume itself is the swept volume. If this is the Vs, therefore Vs is equal to V2 minus V1. Vs is pi d square by 4 into L, swept volume, cross-sectional area of the piston. This is the cross-sectional area, and movement is stroke. It is circular, pi d square by 4 into this L will give you the swept volume, V2 minus V1. Pi Diameter is given. The diameter is 400 into 10 to the power of minus 3 square divided by 4. L is 490 into 10 to the power of minus 3. You will get V2 minus V1. Substitute this here. You will get atmospheric pressure. It is how much? Atmospheric pressure is 1 bar. 1 into 10 to the power of 5. V2 minus V1 is 5 into 400 into 10 to the power of minus 3. Because most of you will forget this square. 4 into 490 into 10 to the power of minus 3. That is integral PdV work you will get. It is 6157.5 Newton meter. It is a positive work done by the system. That means system will move outwards. Integral PdV. Therefore, net work done. Now, net work done, it is given. It is minus 1965 Newton meter is equal to integral PdV, that is 6157.5 plus stirrer work. Now the unknown stirrer work you will get here. That stirrer work you will get it here is equal to, it is, you will get minus 8122.5 Newton meter. Now for a stirrer work, you know, that is minus 2 pi n t into t. That is minus 2 by n t will give you power, but t will give you in terms of work, in terms of joule. Minus 8122.5. Therefore minus 2 pi ns 750 revolutions per minute. That is 750 revolutions per minute. I will convert into seconds. Torque we have to calculate. In the time it is 10 minutes. Let me convert into seconds. 1 minute is equal to 60 seconds. Therefore 10 minutes is equal to 10 into 60 minus 8122.5. Only unknown term here it is torque. Therefore torque is equal to 0.172 Newton meter. That means the first thing we calculated, that is torque. Now the second thing we have to calculate, that is what is that? Compute the torque in the driving shaft and shaft power output. Shaft power output, it is given by shaft power output from the motor. Shaft power output from the motor. But from the motor, that is shaft power output from the motor. That is minus 2 pi n t. That's the t. That is shaft power output. Therefore, it will become plus 2 pi n. It is 750 divided by 60, and the torque it is 0.172. Then the answer shaft power from the motor you will get it is in seconds. Therefore, the answer will be in joules per second. Newton meter. The torque it is Newton meter per second. That is joules per second, or else it is watt. The second one they have given, that is you have to calculate work done of the battery. And another thing you have to calculate work done of the motor. Therefore, this is the motor which do the steering work, and motor is run by a battery. They mention work done battery, it is electrical work. Therefore, the electrical work we will calculate E I into time. Therefore, voltage is given. Voltage is they have given, it is 24, and current is 0.9. 24.9, and the lasting time is 10 minutes. 10 into 60 to keep it in seconds, you get 12960 Newton meter. 12960 Newton meter. This is work done of a battery. And that's why you will calculate. It is electrical work. This is electrical work. And from a motor, if you observe what is the work of the motor, network of the motor, it consists of two things. One is work done by the battery plus work done by the stirrer. If I consider motor as a system, battery work is what? On the system. Stirrer work is done by the system. Therefore, this is minus, whatever the answer will get here, it is minus work done on the system, 12960, and stirrer work, it is work done by the system. But the stirrer work is how much? What stirrer work? Stirrer work is here, it is 8122 minus, but here it is work done by the system. You just have to take the quantity, that is 8122.5. Look at this very important step here. After considering a motor as a system, there we consider whatever the fluid inside here, it is system, work done on the system, there it is minus you will get. But here, after considering a motor, work done by the battery on the motor, here work done by the motor on the stator. Therefore, here for a motor, battery work becomes on the system. Therefore, we took minus. Here, stirrer work, it is work done by the system positive. Therefore, motor work you will get around minus 4837.5 Newton meters, or else it is joules, or else minus 4.837 kilojoules.